Okay. Well, for people who are joining this live stream, this is one of our infinite series of meetings about additions to Wolfram Language. We got a couple of small topics here today and then a big topic. Let's start with a small topic. Okay, first question is whether we should have a function symmetric difference, which is a set operation, right?
Yes, so this is aligned with union and complement, and it's that.
Do we have an analog of the symmetric difference for things like in the computational geometry system and things?
I don't think so yet.
What is region? There's a region. What is region difference?
It's one minus the other, but not the symmetric difference.
What is the symmetric difference of two numbers? Or is that not a meaningful thing to ask?
I don't know of a definition for that. So in this case, this would be the area that belongs to one of the regions, but not both.
Right. I don't know. Is Michael here? Does Michael have an opinion about this?
I think it's a good thing to have.
Okay. Is the name right?
Right.
I think there's little to choose.
Okay.
And it behaves like union, and it's exactly this implementation. So it doesn't preserve order. It works with things that with head other than list. So we implement exactly this definition.
I would think so. I would think so. All right, that was easy.
Okay.
All right.
Okay, so this is a suggestion from a user, which I think it's a good suggestion. And it is that we have intersecting Q and disjoint Q as functions of two arguments. And the user suggested that we could make them var arg, and then they would behave basically like same Q and same Q too. So they would be comparing several lists or at the same time. And this allows efficiency improvements.
Yeah, it's similar to co-prime Q and things like that, right? But co-prime Q is var args, isn't it?
Yes.
Well, that's true if all pairs are relatively prime, which is a little different from unsame Q, which says they're all different. Is that correct?
Yes. So here in intersecting Q, it would be they all intersect, and disjoint Q, they are all disjoint in pairs. So I think that this follows very well same Q and unsame Q.
Wait a minute. Unsame Q has the feature that if any two, I see. Right, no two are like in all possible n squared pairings, correct?
Right. They have to be all really, really different. Now, the only problem with intersecting Q and disjoint Q is that we have an operator form for them, which may kill the var arg case. Now, something good is that we have then
we're not documenting the operator form.
We have contains any and contains none, which are exactly like intersecting Q and disjoint Q, and they do have also.
But we don't document the operator form if there is one.
I think that there is.
Well, we don't document it, so we're not committed to that. We're in luck. We don't document it.
Okay.
I mean, if it even works, we can try it.
Let's try it. I mean, the report was mentioning it, but let's try. Write another one. Yeah.
Okay. It works, but it's an error right now.
So I would say the var arg extension is more interesting
Mm-hmm.
And then we introduce a true difference between contains any and intersecting Q, for example.
Mm-hmm.
That if you want to use the operator form, use contains any.
Does intersecting Q? Yeah, it does reference contains any.
Mm-hmm. And probably in properties and relations there we show. Yeah, it's the first example.
Nice, but why is that? Oh, I see, intersecting Q there.
Oh yes, the second one, exactly.
Mm-hmm. Looks good to me. Good suggestions.
Mm-hmm.
All right, that was easy.
Okay, good.
Let's move on to the real meat here.
Yes, so we're going back to around examples, and I wanted to go again through a variety of examples, check that we agree with what we have. There are some questions.
I'm running the prototype build here.
Exactly. For example, it's not clear what to do with relative errors.
Okay, let's look at this. I have a question on the live stream that I simply don't understand. I believe it is most important to overcome a transcendent equation. I don't know whether that related to anything we were talking about with intersecting Q or anything. I don't understand the comment. If it related to something we were specifically talking about, please explain how and remake the comment because I'm interested. Okay, here we are in the prototype build with various errors happening. Okay, Let's start off with basic examples here. Okay, this is a magnificent function. I mean, so if I take this and I simply say squared, for example, oh, that's so magnificent. Cool. Okay, what happens if I say 1 over this? Magnificent. Now let me try. You know what I'm going to try. 0.1 plus or minus 0.3. Okay, 1 over that. Is that right? 1 over, I see. So 1 over that, it contains 0 within its sort of error bound.
No, it is not a representation of the true mathematics of doing a probability distribution. It is a set of fixed rules how to deal with them. And
Right.
it's up to you to make sure that you're in a regime where you can do it.
Right.
Fair enough.
This is assuming linear propagation of errors, which is also only reasonable when they are small compared to. So we can see later how to do higher order propagation of errors, and then this will get larger.
Someone's asking on the live stream, by the way, a very obvious question in view of what we already talked about, which is, could symmetric difference be Verogs?
Interesting.
I wouldn't think so.
It would have to be something like
a pairwise difference. I mean, it would be what it would be is the always pairwise, the union of the always pairwise complements.
Yes, I think so. I think it would have to be comments.
A complement has a distinguished first argument.
Exactly.
Right, exactly. But I mean, what it would be take all the two tuples, right? Take all the given. Let's take the ABC case, right? That would be
the wiki page has a pretty nice explanation.
Oh, so there is a Verogs version of it.
Yeah.
Yeah. I think we would need n complements, having each element first and then all the rest, whose order do not matter.
Let's see what this talks about. N-ary, symmetric difference. Operation of multi-set, giving the set of sets which are in an odd number of sets. That's a little weird.
No, I was thinking it might be something like that. That's very much like what exclusive OR will do.
Yes.
I don't know if ours will do it, but in general.
No. Our exclusive OR absolutely does that.
Okay, good. That's the right thing.
Oh, nice article on Wikipedia here.
Mm-hmm.
I mean, it seems like if we're going to implement this, we might as well implement the N-ary case if there's no ambiguity in how it's defined, which doesn't look like there is.
Well, we would have to check with the geometry team, because this may end up being like the various definitions for polygons when they cross.
Yes.
And
the region version, yeah.
There are several possible choices.
Right. So the question is whether region symmetric difference, how that works.
Right.
Mm-hmm.
Okay. Well, let's ask.
Mm-hmm.
I mean, there's a related question of how we deal with regions with self-intersections, with defined by boundaries that self-intersect.
Well, something that's coming in the next version are holy polygons.
Mm-hmm.
Finally, after all this time. So we get to do Antarctica properly, perhaps. Or no, we get to do Lesotho.
Exactly. Yeah. It's going to be
not Lesotho, South Africa.
Well, quite, yes. Right,
Yeah.
Right, exactly.
Uh-huh.
And does Italy have that same issue with San Marino?
Might have it with Rome, the Vatican.
Yeah, it has it with the Vatican, yes.
Yeah.
Mm-hmm.
Okay. All right, let's keep going here.
Yep.
Okay, so how do you feel about the name around? Are you happy with it at this point?
It's the sort of thing I'm used to it.
It's a good first approximation.
Yes, but so what I was going to say is that I've noticed that you, Stephen, when you refer to this function, sometimes call it about. I was wondering whether that means that you prefer about to around.
Well, it means I don't have a good enough memory after all the different times that we went back and forth on those.
We're going around and about.
Yes, but between those two, do you have a preference? I don't.
I think I will say I think they're both good, but it's going to be a little tricky for documentation, I guess. It's like these are such generic terms that people may not just get it. I don't know. Well,
I mean, the point is we get to feed a certain number of generic terms to mean very definite things. The reason I think I prefer around to about.
Mm-hmm.
I just think about could mean more things than around can mean.
Sure, having to do with text translation. This is about some topic or
something like that. I'm not sure we'll ever use that, but
right.
It seems, I mean, around has more of a sense of continuous place or something than about does.
Yeah.
But it is the case that when you talk about numbers, you say it's slightly more common to say the result is about 7.2 than the result is around 7.2, although both are possible things to say.
I agree. Around is better in this way. I think it almost, if one was to confuse it with something else, it would be with something related to nearest, and that's not the worst of confusions. At least
yes,
puts one in the right, sort of meaning ballpark.
Right. And we have, in terms of the input with plus minus, we have a glyph that we're going to use for that.
Not yet, but yes, we will have specific.
Right, but we're not using the escape plus minus glyph. Is that correct?
Also veto this.
Yeah. Right now, I don't think we are using it, but the plan was to avoid changing anything related to plus minus.
Well, I understand. I agree, because
Yeah.
plus minus has a different set of meanings,
Exactly.
which means we probably need to render this glyph a tiny bit differently.
Exactly. Yeah.
Have we done that yet? We haven't done that yet.
No, not yet.
What do we think we're going to do to make it different? We could center it. I don't know what it's reasonable to do. I mean, centering it would be at least a hint.
Mm-hmm.
I mean,
Perhaps
and
different size.
We could make the second argument a little bit smaller, which would make
Oh,
it
yeah,
feel like they belong together.
That's a beautiful thing to do. Yes. I mean, let's see what that would look like in terms of, I think that would be beautiful, but let's see. Oh, it doesn't work. Where does it not work? What is that structure? Well, here, I'm sure I can do it with 0.1 plus escape plus minus 0.45 or some 0.045. Okay, now let's go in here. Malparfactics. Yeah, that's rather beautiful. I think that will make it very clear what's going on.
Mm-hmm.
Now, would we? I mean, that's not the glyph itself, though. I mean, the glyph.
Right.
Well, I guess that makes the whole thing clear. I really like that idea, and that then is then this case here, we might go even smaller for maybe a point smaller for those things. I think that maybe should be centered. So how do I do that? That is a how do you nudge? Is it command?
I think command arrow.
Oh, I don't know how to nudge here. Who knows? George on the live stream is pointing out that on a Mac, plus minus is Shift Option plus. But I wonder whether that is our glyph for Shift Option plus. Yep. Okay. And I think that's the current. Oh, great. Yeah, that's the plus minus function. The problem with plus minus is that it means something different. It doesn't mean around. It means potentially plus minus, as in A plus minus B plus minus C, which has a perfectly good mathematical meaning that isn't this whole thing with errors.
Right. And that's why we also have a minus plus that doesn't have any meaning in error propagation.
Yes. I mean, it is a shame that it's not more readily typable, because, the fact that there's a shortcut for typing this, it's a shame. It's a shame that glyph can't be more easily typed. But we've been through this multiple times before, and I don't think we can. I mean, we don't actually absolutely have to cross that bridge right now, but we need it. It needs its own glyph.
Mm-hmm. Yeah.
What do we think the escape key will be for that glyph, for the glyph for around?
I don't know.
I mean, there's things like A plus minus, which is kind of yucky.
UC.
What does that mean?
Uncertainty.
Well, that's not what we're calling around. If we listen, by our conventions, this would be escape AR or some such other thing, which right now is not taken. It appears that arrays is taken for the things which show up in the first point of arrays, and okay, well, that's a boy. That I should have that in the that goes along with this. Wow, I never realized that we have those fine Wowee. Okay. Well, never mind.
What about the tech PM?
I don't think that helps, because I think that as soon as it's something to do with plus minus, we're back in the box.
Yeah.
Mm-hmm. Yeah, I think AR is quite reasonable.
Right. I mean, there's a question of how people will actually input these things. In other words, if they're getting them from somewhere else, like they're typing in a whole bunch of, results from some random, physics paper or something, it would be lovely if they were able to use some keyboard shortcut for this thing. I mean, of course, in principle, we could support some keyboard shortcut for this. We'll have to see. But okay, the plus minus thing. Okay, let's keep going. We've got lots to discuss about the functionality of this. Mm-hmm. Okay, so this is the asymmetric case. Beautiful. Mm-hmm. Symbolic case. Beautiful, beautiful. Okay, what happens? So are all operations supported here? So if I do, so let me try an example here. So let's say I say around. Oh, that's an interesting point. If I'm saying, okay, around random real, I don't know, -1 to 1, and then let's say they're all 0.05, and let's say we make a table of a 3x3 array of those things. Okay, hey, this is pretty magnificent. Okay, now, drum roll, will this work? Is that right?
This because it's basically considering those things as symbolic, and then all the operations are performed by plus and times.
Okay, so if I say something like this, and now I take that dot the original one. Drum roll. Let's see, what does this look like? So let's take a look.
Perfect.
That indeed looks very nice. It's great. I mean, I don't know the error. That's actually quite interesting how the error propagation worked.
Brute force.
Sorry, what's the question?
No. Michael is saying this is being done internally by brute force.
Yes, the standard formula of partial derivatives and.
No, I think what Stephen means that it basically made the symbolic determinant and then the symbolic determinant evaluated. So this scheme is not feasible for, say, 1,000 times 1,001.
Right. Yes.
Do we have a hope of being able to do that?
Well, this is the sort of thing that we would have to go into the functions themselves, like that.
Is this related to automatic differentiation in the end?
It's
ever so slightly.
In some cases, yes.
Well, this is the sort of thing in which how would I say? So it's a bit like an array of quantities versus a quantity array. If we have a quantity array, functions can detect it immediately and do operations as a whole. But if they find an array of quantities, they will basically detect it too late, and the operation will be done quantity by quantity.
No, I think it's actually harder because even if you would detect it, you wouldn't know how to do it.
Well, you can also do some sort of linear manipulation of arrays if needed. If we had some sort of a run of an array plus the array of the uncertainties, we could do something.
But for determinant, it's not clear to me how to do this.
Okay, but in any case, I mean, of course, what will happen is in time, people will want really huge examples of this. But at the beginning, the fact that it works at all is really nice.
Yes, we may end up with an around array or something.
Yes. Okay, let's keep going here.
Mm-hmm. Yes, so this is an area that books on uncertainty always discuss at length, which is what are the rules to decide how many digits you have in the uncertainty.
Yep.
And the rule we are implementing is one taken from the particle data booklet.
Mm-hmm.
And it basically is when to change from 2 to 3. And it's basically at 35. So for example, we see there in the third case at 22. So that's at 22 because it's smaller than 35. If it was a 36.
What is 22 to 35? What are you talking about?
Yes, the third example. Go to the third.
Yeah.
Yeah. So you see that the error has a 22.
Yes.
So the question is, why are we showing 2 digits and rather than 1, just a 2?
Oh.
And the answer is because 22 is smaller than 35. So if it was a 31, we would still show.
What are we talking about? 31. Where's 31? Sorry, I'm completely not understanding.
Yes. So the idea is we take the 2 first significant digits of the uncertainty, which in this case are 22.
Yep.
And if they are larger than 35, then we take only 1. So for example, if we had that the uncertainty started with 47, we would round to 5, and the error would be 0.005.
What on earth? Where on earth did that rule come from? Why is 35 a relevant thing?
Yes. So the idea is that you want to round errors without losing too much error. So for example, if we had a rule of always keeping 1 digit, we might be converting, say, 14 into 10. So we are losing like nearly 50% of the error.
Yeah, I understand.
So that's not accepted. And some people follow a rule of 15, which is anything larger than 15 is 1 digit. Below 15 is 2 digits. Some people follow a rule of 25, and some people follow a rule of 35.
Boy, I never thought about this before. Okay. Are we going to be able to parameterize this in some way?
Right now, we are not. But yes, I guess the question here is whether we should.
We should. Given the arbitrariness that you just described, we should. I mean, most people will be happy with whatever we decide is the default, not least because, for example, I've never thought about this before. At least I don't think I have. Where would we put this? In number form or what? An option in number form? What does number form do in a case like this? Does number form get all ensnarled here?
I don't remember whether it's prepared to do something. No, I think right now number form is seeing this as a symbolic object and not doing anything. But we certainly should prepare all the number form variants to report numbers in scientific form.
Yes, exactly.
But I think this is independent. Perhaps should be not a system option, but perhaps some sort of dollar variable somewhere.
Well, like dollar print precision.
Right.
What happened to dollar print precision? Did we rename it?
No, I think in the end, we only have the option.
Oh, and where is that? I see. It's a front end option. Yes, it's an option. It's a style sheet option.
There's probably a kernel version too.
A system option, you mean?
A system option, yeah.
Yeah.
It's funky. I mean, given the fact that that isn't even exposed, it seems crazy to expose this, but probably they should both be exposed. I mean, yeah, this is an interesting, bizarre thing. I mean, because obviously one of the big issues is how many digits do we display in that case, right? And that seems to me to be a bigger, more obviously big deal than this case here. I think they should both be given some. Maybe they should both be dollar variables.
I mean, we could also have an option in a round itself. So far, a round doesn't have options, but it could have.
Yes, I understand. Well, what happens if you combine a bunch of things with different decisions about their printability?
Yeah, that's a good point. I don't know. And I was thinking that perhaps a round should have mathematical options, not so much typesetting options.
Yes. But also, I think that, we want some local form of this. That is, just like number form can be a local way of specifying, within this column of this table, I want it to typeset this way. Right?
Yeah.
Okay, so look, yes, let's figure out how to do this. We need to parameterize this, but let's keep going right now here. Okay. I hate the trailing periods here.
I see.
Do we really need them?
Well, I mean, not representing the fact that these are approximate numbers.
It's obvious they're approximate numbers. You can't have a useful around. Well, I mean, can you in fact have an around? What does around do? If I say around 10,2, for example, yeah, that's what it does.
Well, but internally, if you do input form, it's still the exact numbers. It's not that it's numerizing.
Okay, so if I say squared of that, okay.
This is for the type setting. The type setting always wants these two
So, I mean, there are a bunch of decisions to be made with this typesetting, right? And you're like this particular, I mean, the very fact that this is displaying in what happens if I try and copy paste pieces of this?
This is the sort of thing that is not.
Yeah, that's not.
It's a mock-up. Eventually, when it's all decided, I mean, I should.
Right. Okay. But so right now, this is typesetting in this floating point form.
Mm-hmm. Yes. The main thing here was that if you have, for example, some formula for the error, it looks ugly when you have exponentials and squares and square roots, etc.
What does that have to do with this? I don't understand. I mean, in this case, I would have expected to see 10 plus or minus 2, not 10.0 plus or minus 2.0.
Well, it's the generic rule that whenever, no matter what you have inside the arguments of a round, they will numerize, at least the error. Because otherwise, when you propagate that through formulas, you start seeing square roots.
I see. So in other words, if I say this, interesting. I mean, it's fairly reasonable what that's doing. It will be kind of crazy to have 10 plus or minus a half. Michael, do you have any thoughts about this?
I think in many more cases, the period will be better.
Okay, but what do you think about, okay, fine. But what do you think about this case here?
Yeah, I know.
Why don't we just strip it?
I don't have a strong opinion.
I think we should strip it. I think it looks ugly and computeristic.
The other possibility there, so if you see, that's an exception to the rule of only show 2 significant digits in the error. So there we are showing 4. The other thing I was thinking about is whether those cases should factor out something times, say, 100 or something, or 10,000 in this case.
You mean and put it in scientific notation?
Yes. So it would be no.
The answer is no, not for a small number like that. I think it's a mistake. But explain to me the 2-digit rule.
Yeah. So we were discussing before that errors only show up to 1 or 2 digits. This rule of 35.
Yeah. And so why did this how did this manage to get out of that?
Because we would have to show 1200 to follow that rule. And then we would kind of converting the 1234 into 1200. That's why I was thinking that perhaps if we factor out, we can keep inside something plus minus 0.12 times 10,000.
Michael, what do the standards say about this? Do you know?
I do not know. Jose studied it much more data than me.
Yeah, I've seen that notation multiple times in the books.
Which notation?
The notation, in this case, it would be something like 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 1, 2, 3, 4, 5, period 6, 7 plus minus 0.12, and the whole thing times 10,000.
Yeah, I mean, the point you're making is that after the 1, 2, those digits there are just garbage.
Well, not garbage, but not useful at all. They are already too much into the error.
Yeah. Gosh, I don't know. It'd be good to see more examples of this.
Yeah. For example, try to do that around and divide it by 1,000 or something like that. 1,000 period. See? So that looks nicer. So sure. The question is whether to represent the original as this one times 1,000.
But by the way, if I put in here 1, 2, 3, 4 point blah 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 blah,
Yeah.
I would just get 1, 2, 3, 4.
Right. Yes. So right now, this is throwing away numbers following the rule of 35, except when they are to the left of the decimal period. Then they are kept.
Mm-hmm. Let's start off this way. I mean, clearly, if I were to do this times 10 to the 7, yeah, that's kind of silly.
Exactly. That gets problematic. So I think this notation I was saying to factor out numbers automatically.
What is that?
This is a message coming from decimal form, because here you wrote, so this internally is working via decimal form and imposing some precision, and it's the combination of those that, you see, those zeros to the right of the number.
Oh, yeah, well, clearly this should have gone to scientific notation, and then all of them would have been happy.
Yeah. Yes. So that's what I'm saying. That there should be some automatic switch to scientific form.
Well, your claim is that potentially, if there are more than 2 digits to the left of the decimal point in the error, that it should switch to scientific notation.
Yeah, exactly.
Maybe you're right. I mean, but times 10 to the 2 will look really weird. Will you ever get that?
Yes, I guess we have the same situation as with scientific form. We will have to have thresholds. Perhaps.
Yes, but as you say, the threshold, as soon as you've got more than 2 digits to the left of the decimal point in the error, you've got craziness.
Yes, but it's not too crazy. This case is really crazy with 20.
Yeah, right.
So
the threshold, I mean, the default threshold you should use should be the same as we use for anything like this, which is, if I do this times 10 to the 20, I'll clearly get that.
Yeah.
So clearly that threshold you should use.
Yeah. The
question of whether you go all the way down and never have more than 2 digits to the left decimal point in the error is not clear to me. It would be nice to look at examples in the literature. I mean, did you look, like in the particle data table, what do they do?
What I see in most cases is the scientific form factorized.
Yeah. I'm looking here. I can't believe I've been subscribing to these books. Well, they may have stopped sending them to me, but I started getting them in 1972. A lot more is known about particles since that time. Okay, what I'm seeing here is a bunch of things where there are 2-digit precision. Let's look at some. Boy, I mean, it just so happens that a bunch of these things are. Yeah, it's interesting. So they've got.
In some cases, they even use 3. Rarely, but in some cases, they are so proud of what they measured that they want to use 3. I think.
Yes. Is there a meta discussion anywhere in this book or elsewhere about? There's also the whole notation of digits and then the last few digits in parens. Maybe you're going to talk about that in a moment.
Yes, further down we discussed that, or having them in gray, smaller, this sort of thing.
Okay, let's take a look at those. So I don't have a great example of this right now. Okay, let's keep going here. Okay. Yes, that's what we just discussed.
Exactly.
Avogadro's number. Okay, that's what we're talking about this.
Yeah.
Well, how would you input Avogadro's number? I mean, is this around? I thought this was 6.023. That's what I remember. Has that changed in the last 50 years? Anyway,
not so much.
Okay, so my memory is just not. That's a problem with my memory, not with the constant. Okay, okay. So how would we input this, and why would it output like this rather than times 10? Plus minus.
It's not necessarily that it would automatically output like that. It's more like, how do we offer the possibilities of outputting like that?
Well, notice that to not output like that, what you would be outputting is 6.022 blah 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 plus minus 0.000074, which is quite ugly.
Yes.
That's why this was invented.
Yes.
So, I mean, if we're going to do this, we should use the same convention of making it smaller that we do for these other ones. But what does this mean now exactly?
It means the uncertainty in the last corresponding digits, also in the 57.
What?
Yes, so you have to imagine that this 74 corresponds to the positions of the 57. So it's 0 point, as many zeros until we get until 08, and then 74.
So wait a minute. This means we've got this number of things. This would be plus minus 0.000074, where the 74 aligns with the position of the 57. Is that correct?
Right.
Exactly.
That's a crazy way to do this. All right. So the question, so it's a graphic design question. Can we invent? So I mean, clearly, if this is what's going on, we've got to tag the 57 as being the uncertain digits.
Yeah.
I think we need a device here that's something. So, I mean, how would we do this? What would be a uniformized way? So normally this would otherwise be around, let's put in that number, 6.022140857, comma, 0.000.
Yeah, 4 zeros more. And then 74.
And now why did it cut off that last?
Because 74 is larger than 35.
Oh boy, this is a subtle business.
That's standard. I mean, everybody agree that. I mean, I've never seen, for example, a rule of 45.
No, I understand. But why did Avogadro's number get a 74 there, even though that last digit, even though the 7 and the 4 at the very end are garbage in a sense?
It's not garbage. It's a matter of how important statistically this will be. And yes, this is mainly a decision of whoever writes it.
Okay, but this, so what we are proposing, what we need is a notation that can involve smaller digits and thises and decoration and so on, that kind of merges these two ideas.
Yes.
Because essentially what's happened is this 57 here, I mean, really what we would like to be able to do, if I were to, kind of indicate it, would be something like, and we can't do this as such, but something like this. That's kind of what we really are talking about here.
Yes.
Yes, but
it's in some abstract sense, because once you reach above 100, it becomes a little bit strange, because you have to go one to the left. The 8 gets changed.
Well, no, I know, but I'm saying the 5-7 is uncertain, and the uncertainty in the 5-7 is plus minus 4-7.
Yeah.
Okay. So the point that I'm making is that that's conceptually the fact that the 5-7 is I mean, it is super embarrassing that I didn't immediately know, although I think Michael has explained it to me before, what this means.
It's what CodeData uses since at least 20 years.
I know. I've seen it many times, but I've never actually needed those digits enough to actually care about what those, what that means. And, I view that as a bad sign in terms of, if we survey typical people who don't, because nobody uses those digits of Avogadro's number realistically for, unless you're doing metrology or something. Right. So I'm embarrassed to say that I thought that 74 was the part that was uncertain, not that it was the uncertainty of 57. But in any case, so the thing that it almost feels like, okay, so let me try one example of a way we could do this. And maybe it's, let's imagine that we could do something like this, where these are
in the past, we discussed graying out the last two.
Yeah. But what about, oops, now I'm making this, now I have to make that bigger to not be so silly.
One thing that I don't like on it gives you the feeling the 8 is in all cases correct, which it isn't.
What do you mean? Why isn't it correct?
Because 57 plus 47 flips the 8 to a 9.
I think that's, look, if we really wanted to be unbelievably cutesy about it, we'd make the 8 slightly smaller.
Something intermediate.
Yes. This, look, that notation is at least clear. I, for example, wouldn't be confused by this. But I understand that the 8 isn't, but nothing is certain. Like in these things here where you say plus minus, you're stating digits and then you're saying, oh, whoops, actually they might not be correct.
Right.
What happens if the decimal point is between the 5 and 7?
Arg. You mean the error is...
Like in the first case in your screen right now, which we have 1.2.
Yeah, I understand. So I see. So the problem is, if there are a lot of, none of this is relevant unless there are a lot of digits. You're not going to want to do this unless you have how many digits to the left?
Oh, I see.
Right, because if you have a small number of digits to the left, you just want to do, like 3 digits to the left, you just want to do plus minus. Mm-hmm. This is really a story of CodeData, metrology, all that kind of stuff.
Mm-hmm.
Now, we could decide that for the time being, we're going to punt on those precision measurement things and just do it this way. Make the precision measurement, the people be proud of how many zeros they've managed to get in there. Mm-hmm. Look, I think this is the direction we should be going for this, something like this. But let's keep going a little bit here. We're kind of running out of time, but let me just see what's happening here.
Just for your amusement, I will put something in the chat.
Okay.
We are up to date with the things.
Oh my gosh, is this what we've got?
Yeah. You see how the uncertainty changed over time.
I didn't know this. It's quite interesting.
Did it go down always?
No, some go up and down. It's complicated. Generically, obviously, it goes down, but there are some nonlinearities and some non-monotonic.
Okay, truly complicated. Okay, all right. But listen, I like an approach like this.
Mm-hmm. So you think
what I would like to try to figure out is how to merge that, what the boundary looks like between the pure plus minus, the pure full number plus minus, and this type of approach. And, clearly we're going to have to parameterize this with some kind of number form or a round form or something. Do we have an around form yet?
Not yet.
Because this would be a reasonable set of things to parameterize in there.
Mm-hmm.
So I don't think we want to subscript anything.
Mm-hmm.
I don't think that's not the right approach. I think we want a plus minus to be in there somewhere. But I take your point about what happens if there's a decimal in the middle. It's a pretty weird case, and we could force that to not be the case by going to scientific notation, because you're never going to be in this situation unless you've got a lot of digits.
Right. Yeah. Mm-hmm. Yeah. So it's a matter of deciding a threshold.
I think so.
Mm-hmm.
Oh, we talked about an round form.
Yes,
okay.
We have.
Great. Yeah, that seems like the right way to do it. Parentheses, none, automatic, whatever.
Mm-hmm.
Sounds reasonable to me. Oh boy, we've got lots of stuff here. Okay. Let me just understand what we're doing with respect to the next meeting, which actually also is intended to be live streamed.
Mm-hmm.
I would like to go on with this. Is Eric here?
Yes.
Could we move the next meeting? Or is that going to be a horror?
To another day or a different time?
I think we probably should move it to another day. Like,
let me talk with Raj. I'll figure it out.
Okay. Okay. From and to intervals. Yes. I agree. That's a good thing to do. We talked about that before. That seems right.
Mm-hmm. Mm-hmm.
Yep. So it just goes symmetrically into the interval and just does the right thing.
Yeah.
Okay.
Yes. Distribution, this is a bit more difficult, but in a sense, all these around are like a form of a statistical distribution.
Yes. So is that, I mean, when people quote 1 plus or minus 0.2, they think they're quoting the 1 sigma.
Yes, exactly.
Okay.
If not otherwise stated.
What do you mean if not otherwise stated? If they say 1 plus or minus 2 at 90% confidence level or something like that?
Yes, exactly.
Yeah.
But so in principle, then, the surround conversion could ask for a confidence interval.
Yes. So the idea, which I haven't implemented yet, is to have an option here, which is a confidence level option. And then you can say what's the actual...
Okay, so then the question is, if you have a confidence level option for a round,
mm-hmm.
doesn't that, if you were carrying that around, so to speak, in a round,
mm-hmm.
then would you expect, okay, so let's say I said 1 plus or minus 0.2, 90% confidence level.
Yeah.
Right? Are you implying that then I would always be meaning 90% confidence level? And then what happens if you try and combine a 90% confidence level with a 50%, a 68% confidence level?
So the idea here is that the uncertainty in the second argument is 1 sigma. If you say that you have a confidence level of 2 sigma or 3 sigma, then you are changing the meaning of that second argument. But in a sense, the statistical distribution is still the same. It's just that you are describing it in a different way.
Yeah, I understand. Well, but so what? Yeah, okay.
It would matter in the moment you try to get probabilities out of it.
Yeah, but no, so do we have any ability to convert from a round to a distribution?
Not right now.
So arguably, normal distribution of a round should convert, if you say normal distribution of one argument around, it should turn it into a normal distribution with a mean and standard deviation.
That's not obvious, I feel, because you might well mean that you are not certain about the mean of a normal distribution.
Right.
I see what you're saying. As opposed to, okay, so the question is, right. Someone on the live stream is asking about the non-symmetric case. We are covering in around. If you're asking about something different, let us know. But in around. Well, actually, let's do an example down here. We should be covering, if we say around 2 minus, let's say, oh, I can't have a negative number there. Actually, I want to ask about that in a minute.
These are both positive.
0.2, 0.7, for example, that will do that.
Mm-hmm.
Now, let me ask the question, since that came up. I mean, it's kind of crazy, and this should probably just be an error. That is weird.
It's not prepared to handle it. Yeah, it should be an error, I think.
I think so too.
Or taking the absolute value.
Or flipping.
What do you think? What do you mean by flipping?
Basically make the left bound the right and the right the left.
But in this case in which there is only one?
Yeah, what about the symmetric error case where the error is negative? Just doesn't make any sense, I think.
Yeah, I think it would just take the absolute value.
Yeah, I agree.
With a message or without?
Without.
I think so too.
Are you sure? I mean, so if I negate this thing, right?
Mm-hmm. So the negation knows that it hasn't, it shouldn't touch the uncertainty. That's why it is preserving it.
Right. By the way, I assume that this, if I do this and I say squared and so on, oh, that's so magnificent.
Mm-hmm.
Right. And then I do square root of that.
Sorry. Sorry, something is very wrong in there.
Well,
but it should go back to the same thing.
Yeah, obviously, right.
Yeah,
okay.
Yeah.
Well, first bug we found in this functionality, I think, in this session.
Mm-hmm.
Okay, let's go back here. So the question is, if you give a normal distribution a rounds as its mean, your point is that should mean an error in the mean, not. I mean, look.
I'm not saying it should, but I'm saying there's some ambiguity.
Well, I don't think there's ambiguity in the if you do this case here without a second argument, I don't think there's any ambiguity. I mean, what's the default sigma in a oh, it just refuses.
Mm-hmm.
Interesting. We should ask Roger and the statistics team about this. I think it will be somewhat useful to be able to get distributions out from rounds, even though, obviously it's kind of nonsense at some level, right? In the sense that we can't guarantee it genuinely will be a Gaussian distribution or anything like that. Now, in the chi-squared, is that a chi distribution, whatever? That's just the mean and standard deviation of the distribution. Is that correct? What happens if it's a distribution without bounded variance?
Right. I was thinking that a round can always take a distribution and return some approximation to it, some sort of normal approximation. But in the other direction, only the normal distribution knows what to do with an round.
Yes, I agree. I think it's hopeless otherwise.
Right. So perhaps it's not worth.
Well, the other possibility would be to have a thing called a round distribution. This may be crazy. To not force it into normal distribution. Well, it's crazy. Because basically the point is the only thing you can reasonably get is a normal distribution.
Yes. Well, there is a slight extension. So a round can take a third and fourth argument with the third and fourth moment. That's all it takes. Because sometimes it's used. But
which is what? A multinormal? Can that be represented as a multinormal distribution?
Not a multinormal. This is
one-dimensional.
So
it's still one-dimensional. Okay,
it
so
just has
yes.
units.
So then
Exactly.
my idea of an around distribution is not completely crazy.
No, but the system, I have forgotten the name. The system has, in the Wolfram language, we have a distribution which can take those 4 parameters. It has a name.
Oh, really?
Of an author, yes. But I've forgotten.
Okay, but so that's a reasonable thing. So, okay, so there is a notion of from and around to a distribution.
Yes.
I think we need to ask the statistics folk. If I don't know if could Eric see if Roger is around? Maybe he would have an immediate opinion about this, or if not Roger, who works on statistics?
Gosia, perhaps? Gosia?
Yeah. Let's see if they're around.
Both or just one?
Well, ask Roger. Okay. Yeah, I'll be right back. And meanwhile, okay, so we function expanding the distribution to a given order. What on earth is this? Oh. Well, what happens if you say mean of and around? Does it do something reasonable? Should it do something reasonable?
Not right now.
How do you get the center value of and around?
We don't have extractors yet. Right now, because it's not atomic, it would be just the first argument.
Do we think mean of an around? Okay, so if I take a bunch of arounds and I say mean of all the arounds, I mean, arguably, a single mean should extract the first. I mean, so what are we going to call those extractors, right? So we got to have an extractor. Oh, here we go. So you're talking about, so I mean, one possibility is if we have an around of 1 plus or minus 0.2, the question is, what's the mean of that? And does that make any sense to be the extractor? I mean, in other words, we could imagine that we have mean and standard deviation be the extractors. Or does that promise something beyond what is reasonable to deliver? What else will we call those extractors?
Around center and around deviation.
Maybe. Does anybody know, by the way, where I'm storing these things? Is there a section?
There's an uncertainty folder.
Okay, thank you. And this is. Okay. Okay, so you're proposing something like around center. I don't really like that very much. That sounds very, very geometrical. And by the way, you know, in the case of an asymmetric thing here, what on earth do we do? I mean, you know, around center, around, I mean, there are different things. We could say around range, around, which could be the complete range, around error. I hate that. Error just sounds wrong.
Well, this does not represent as a range. This does represent the distribution.
Yeah, I agree.
Roger's not answering. Which Gosha should we use?
Gosha K.
Gosha K.
Yeah, don't get the wrong one. Okay, so look, we need these extractors, but I don't know what they should be called. At least I assume we need. Yeah, I mean, we ultimately we need these extractors. I don't think it's reasonable to. It's like, you know, in the rational number, you could in principle say first, but you really maybe you can't even now. But you know, you really want numerator. What do these have an official name in the literature? The the center and the uncertainty. Do they? Well, the uncertainty is called uncertainty, but what does the uncertainty mean? Does it mean the 0.2 or does it mean the 0.4?
Sorry, you were breaking up.
Oh, I'm saying, does the uncertainty mean the 0.2 or the complete range 0.4?
No, I think it's 0.2. It's the sigma, which is called uncertainty. Yeah. So it's a Pearson distribution. I was looking through the distribution. The Pearson distribution can handle these 4 parameters I was talking about.
Okay.
So it has all these numbers there. There is a some formula to convert, but it's this object.
What the heck is that first thing there of a type? That's really weird.
Yeah, I think the types are numbers, and there are like 7 different types.
Which probably old Carl
yes.
Pearson wrote down one day, and he put on his piece of paper 1, 2, 3, 4, 5, and now we're stuck with that.
Hello, Gosha is here.
Oh, great. Okay, we are talking about errors, numbers with uncertainty. Hey, you guys can explain what it is. I'll be back in just 1 second.
Yes, so we were talking about around and the extension to support more moments than just the first one. And then I was mentioning that around currently can support also skewness and kurtosis. And that's similar to what this distribution does, the Pearson distribution, which somehow these numbers correspond to the first 4 moments. And yeah, Stephen wanted some sort of comments or confirmation of that. Because he was wondering whether around should have its own distribution function, some sort of around distribution, which represents what around is doing. So for 2 arguments is the normal distribution. With more, it would be a normal plus kurtosis or a normal plus kurtosis, no, skewness.
But normal has fixed skewness and kurtosis.
Right. So if you take a distribution with only 3 moments and the rest are zeros, all other moments,
yeah,
assuming some condition that makes the whole thing converge and that sort of thing, I think this is Pearson distribution.
Hi, guys.
I think I actually read that Pearson created this distribution precisely to understand the meaning of the first 4 moments.
So wait a minute. So what did we figure out here?
I was explaining, Gosia, the relation between around distribution and this Pearson distribution, potentially.
Mm-hmm. But so the issue is, with around, look, around is a linear approximation to error propagation. Although I don't understand these 3rd and 4th moments. Are they going beyond the linear approximation?
Well, more than linear. So there are here 2 things. One is the distribution we start with, which rather than being symmetric, it's a bit asymmetric because we are the skewness and kurtosis. And then the propagation is the formulas we use to transform the distribution, which in the statistical framework, there is this transform distribution, which will do the exact thing. We use a linear or quadratic or cubic approximation. I think I have formulas up to level 4, up to degree 4. And that's the role of a round replace. A round replace will know to which order you want to do the propagation.
Okay.
So there are examples further down, but these are 2 independent things. The distribution you use, which is either you use normal or something that has more moments, up to 4, and the, say, order of differentiation during the propagation.
Okay. Someone on the live stream, by the way, is asking, shouldn't it just work if you replace every use of around with normal distribution? Well, actually, it's not clear. I mean,
no.
From an efficiency point of view, absolutely not. From the point of view of okay. What is the statement on that?
So I think the answer is no, because, for example, you can add 2 arounds, but you cannot add 2 distributions. Right. So the distribution it plays a role of something symbolic that used in the statistical framework in a very definite sense. Around is something else that represents effectively the same thing, but it's used in a very different.
Well, so let me just understand something. So if I say around, okay, so here's an interesting case. If I say around 1, okay, plus around 1, 0.2.
Mm-hmm. Yeah.
What would that do for two distributions? If I have two normal distributions.
What if you do 2 times around 1,
Yeah, that's
1.2? That's the difference.
Mm-hmm.
That's the independence.
exactly.
How is your arithmetic working?
Yeah, right. But now if I had two distributions, do we have a mechanism in the statistics framework, in the probability distribution framework, to add two independent distributions?
Transform
Yes.
distribution.
Transform distribution, yes.
So if I were to say, what is it?
Transform distribution of x plus y. X is a normal distribution and y is a normal distribution.
I see.
Uh,
Like this?
Yeah.
In a list, yes.
Both x and y are normal distributions. With, in this case, I would say mean 1, standard deviation 0.2.
Well, that's not gonna work because x and y have to be assigned independently its own distribution.
Yeah.
So x distributed as normal, comma, y distributed as normal.
Okay. Oh, I see. Otherwise, I mean some vector distributed somewhere, which is
Right.
completely different.
Yeah.
Okay. Fascinating. Well, it's good. It gives the same answer. Okay. Will it always give the same answer? So if I were to do this, if I were to say,
When the uncertainty is small, yes.
Yes, and the linear and the formulas are linear, right? So then there's going to be some difference there. And the point.
why wouldn't it do that? Why didn't it do that?
There's zero chance to get a closed form for this resulting triple integral.
Right.
You may operate with finding the properties on this, but it just doesn't have the closed form, which would be the head defined in the system.
Do we have a single function mean standard deviation? No, probably not.
No.
Okay, but so the around of this thing should arguably be, okay, so if I say mean of line 45, it's going to grind for a long time.
And return unrelated.
Really? Even the numerical integrals can't be done? Is it, Gosha, do you agree it's going to return unevaluated here?
I don't know.
Okay.
Yeah, this is probably now the responsibility of integrating.
Yeah. And most
why
likely
isn't it doing?
Because it has the machine precision in the parameters. So yes.
So this is the sort of situation in which around will do some linear approximation and get something, but of course it's not exact.
George on the live stream is pointing out, wouldn't one use around in case where there was some knowledge of error, but the error distribution is not known? Absolutely. It's in the usual sloppy way that it's done in empirical science, where you absolutely have no idea that it's a precisely a normal distribution, but you have some sense that the error is 1 plus minus 0.2. Yep, no, completely. That there are yeah, this is kind of error propagation, the way error propagation is typically done in the empirical sciences. And what we're now talking about is the interface between that and very precise error handling in distributions, which we want to make as reasonable as possible, but we know perfectly well that we can't, it's not going to be precise. So, okay, so let's go back here. So the question was, there are two questions. How do we, what is the interface between, we were talking about whether around can be an argument to normal distribution, whether, for example, we could say normal distribution of around to get a normal distribution which has the mean and standard deviation corresponding to the parameters of around. And potentially, see, I think we're going to need something else. I think we're going to need something which is an approximating distribution based on around, which will turn into one of these Pearson distributions with all of its fancy moments if the around has more. Because I mean, even this case, I have no idea what the asymmetric, I mean, what distribution is that? What should that turn into?
So the way this is done, I haven't read much literature about this, and there is no agreement. So the way this is typically handled is by considering that you have two normal distributions, one with 0.2, one with 0.3, and then manipulating them separately. There is, Roger told me about a way of having a distribution which is some sort of merging of two distributions, one on one side, another on the other side.
That's splice distribution.
Right, exactly. So I think
we have that.
Mm-hmm. Yes, so you can kind of glue them together.
Yeah.
Okay. So what do you think, Gosha? What do you think we should do here in terms of, I mean, it seems to me we need a function that will just do with a variety of possibly different method options.
But could we not just use probability distribution as a one arc?
What is probability distribution?
It's the interface to define arbitrary distribution. I mean, by any function PDF, so the probability density or CDF potentially, but you need to decide what your density is, right? I mean,
right, which we decide based on what kind of internal parameters the round has.
Right. So your proposal, Michael, is that probability distribution of around, I mean, this seems kind of nice sounding, of around 0.2 would be, that particular one would turn into normal distribution, or it might turn into empirical distribution. Probably it will be most civilized for it to turn into normal distribution.
I think so too.
Okay. Gosha, what do you think of this? Do you object to that?
I mean, if you want a round to follow normal.
No, that depends what's inside the round. There might be higher moments in the round.
Right. So for example, this case here, one would have to make a decision in that case, and that would probably have to be a method option to probability distribution. In that case, one would have to make a decision what to do with this.
My question also would be, would you allow infinite moments?
In a round? No. You're out of the game. If you say, look, if you, okay, so here's an interesting question. Okay, let me give an interesting case. All right, what about this case? 0.1 comma infinity. Are we supporting that?
No. Well, it typesets, but the formulas will collapse at some point. So when you say, Gosia, infinite moments, do you mean an infinite number of them or infinite values?
Infinite values.
Yeah, so an unbounded
Cauchy distribution, right? I mean, it has heavy tails or something.
Yeah.
So this case here doesn't seem completely stupid to me, around 0.1 comma infinity. That means it can't be, it's not likely to be less than 0.9, but you don't really have an upper bound.
Well, but you see, in practical applications, the errors are always assumed small. It's the basis of all this. So writing infinity it goes against that.
Okay, what about, but on the other side, going to 0, I mean, aren't there cases, okay, in the particle physics business, for example, there are things where, I think, where there are parameters, there's certainly parameters where you don't know, it could be just absolutely 0.
It could, but again, these errors do not represent ranges. I mean,
it's the measurement error, right? That's what you think about. Yeah.
So there shouldn't be a way of limiting. This is just an estimation of what the error is. So that's why 0 and infinity don't seem correct here.
Okay. Well, then we should specifically disallow this and error out in this case.
Right. I think so.
But okay, but let's take, so the answer, Gosha, to your question about unbounded variance and so on is no.
Cool. Right, so then normal, it's the usual way to go, yes.
Right, but in this case where it's asymmetric errors, we've got to decide what to do in that case by default. And then the next case is if there are higher moments specified, then we've got to have a distribution which has higher moments in it.
And that's because some people do it, so I've extended it, but I've never seen more than 4. So the first up to kurtosis. And that's what it's supported here. Because for speed, I have hardwired the formulas, and these are complicated. These formulas are serious formulas that become very complicated when you increase the
Okay, but I think, look, bottom line, this seems like a sensible way to go. I mean, frankly, this is, to quote, it's kind of it's like von Neumann's quote about random number generators. I mean, this is sort of a state of sin type thing. To convert an around to an actual official probability distribution is, it's kind of silly. But it's also will be particularly, I mean, there will be cases where it's interesting to do that, even though you're kind of deluding yourself because you don't really have that amount of information. Fair? I mean, I think this is...
I think it will be useful.
Fine.
I find it like informative.
Yeah. Okay. Fine. Well, let's plan to do it. And what other functions do we have to support from the statistics framework with around? Probably a bunch of stuff, ultimately. Like, for example, a normal distribution with an around parameter is a whole different story.
Probability might be one of the first ones.
I wouldn't go too far there. It's a very slippery road.
But probability seems pretty natural. Like you have around and you want to know what are the chances that my real value is between this and this.
Yes,
that's how you go deeply into the state of sin situation, right?
But I think because you can compute the probability distribution, you first do that, and then you are in full statistics mode and continue.
Right.
I don't think we should try to support. I think, anything like that, people are going to quote, they're going to think they're going to get p-values out of the thing and all kinds of crazy stuff, and it just doesn't make any sense.
Nope.
Yeah.
I mean, they'll get stupid answers with p-values anyway, and the literature is full of stupid p-values, but let's not contribute to even more of those. Okay, so the only other question here that related to this is whether mean should do something on around itself. I think it's a sensible thing for it to do. Although, is it inconsistent? If I were to generate a bunch of arounds here, I think I had some up here someplace.
Right.
And then do mean. Okay, so I have a bunch of arounds here. Clearly, wherever I was down here, clearly I want the mean. Oh, blah. Well, so much for that. Okay, never mind. Okay, let's make some arounds here. Okay, now if I say mean of that, magnificent, right?
Right. So mean of a number doesn't work, right?
I believe that's correct. Yeah.
So probably mean of an around shouldn't work for the same reason.
Well, but mean of a probability distribution does work.
Yes.
So it's not the case that mean doesn't have any. Why? Oh, yeah.
Is it 0 perhaps?
0, 1, yeah.
Okay. So that's why I think mean of about should work, of around should work. And I made my same mistake with about and around just then. I think it should work. I think mean should work. I think standard deviation should work. Now, the next question is, should kurtosis...
But the mean, would it really always return the first argument?
Well, that's my question. What if you have two least in the second argument?
Okay, so your case is a round of 1, 0.2, 0.3. You're asking...
It must be consistent what we do with the transformation to distribution.
Right. So that's why I think the idea of having an extractor that extracts the one is a good one, but mean, I would prefer people to have to ask for a probability distribution and then do mean of that.
Yeah.
Okay.
So it's that's the value of a round.
Because otherwise they will ask for a round to be supported as a distribution in other places, and it's going to be a slippery road.
Yeah, no.
Yeah, someone on the live stream is talking about t-distributions and saying there should be intelligent distribution assumptions about what distribution an empirical around corresponds to. Yeah, I mean, that's kind of what we're talking about. Is the minimal case is supposed to be a normal distribution. I mean, we would get, if I'm remembering my statistics correctly, we would start getting t-distributions if we put in the normal distribution, if we had some parameter. Actually, I don't even know how. What is the distribution you get if you have a normally distributed mean in a normal distribution? Isn't that, well, I don't remember what that is. No matter. Okay, but in any case, yeah, I mean, look, by default, I think what we should do is probability distribution should, by default, you should decide what this should be by default, but we should have a method option which decides that it could be something different here.
Right.
And I don't know what distribution, okay, so, all right, so we've killed the idea of mean operating directly on a round, which is fine. So now what are we going to call the extractor that extracts the center value? It's not, is it the center value? It's not necessarily the center, as you point out. In this case, it's not the center.
It's the value.
Could be the value, though we had discussed in the past having an around value that is able to extract multiple things, not only the mean.
Oh.
A bit like date value.
Well, that sounds like a good thing to me.
Something
that
that's
the right thing. So around value would by default extract just the main value.
Right.
And then, yeah, why not? And then we can, because I don't think this is going to be a particularly common case to ask for the uncertainty. I think this is going to be a common case because I think it's going to be like, I don't care that these things have uncertainty. I'm just going to barrel ahead assuming that it's the main value. So I think that's the right approach. So around value with a second like date value.
Right.
Good idea. Okay. All right, let's continue here. So what is around expand?
That's something we had considered in the past, but related to this idea also of expanding the around into some distribution at some order. But yeah,
seems kind of crazy to me. Seems like we're putting too much precision into something which is, where there's never really going to be precision.
Right. Exactly.
I have a question though. What is the way, if I've got a table of numbers and I want to get from, okay, yeah, here's an obvious question. Okay. So I've got a table of numbers and I've, let's say I've got, random real between, 0.8 and 0.9. Okay. And I've got 20 numbers. Okay. And now I want to turn that into an around. Do you see what I'm saying? So I've got a bunch of experimental measurements and I want to turn them into an around. How do I do it?
Well, probably we need some of the fitting functions to do that. Right now, it would be a round of the mean, comma, the deviation of that.
Right. But to me, it seems like we should have a function that, because that is the case, right, is that you've got a bunch of, I don't think there's any other case. How do you get an around? You have a bunch of measurements and you want to figure out what the, you assume, now in the case of, okay, so how would I get a normal distribution out of this? What do I get what's the,
the estimators are exactly as Jose said. So we'll take the mean and the standard deviation of the least.
No, I understand, but how do I actually get it? What's the function?
Estimated distribution, you put this data in, so this random real, and then comma normal distribution, A comma B.
Why do I need the AB?
You need to put the parameters, and it's also symmetric to the, you don't need the AB over there. It's just normal distribution. And to be when you ask for started with find distribution parameters, and then we would return the rules for the parameters.
Okay.
And some distributions take more than just, one set of parameters, may have more. So then you know which signature we're looking at.
Okay. But how does it know? I mean, would this support a pattern here as well? It's just very weird to have those hanging, symbolic variables there.
Excuse me, while Gosia's, I'll be back in a moment.
Yep. Okay, but don't you think we need a function, Michael? This is, it seems to me we need a convenient function that doesn't involve going through distributions here to go from this to an about. Okay, question is there a return around? When Jose comes back, we'll talk about about.
I mean, distribution is not the right word. We want really an around. Two around or something like that.
Yes. No, absolutely. I mean, from this, we really want to be able to take this thing and we want to say, what is the right term for it? I mean,
if we would have your earlier mentioned mean standard deviation, we could just chain them.
Yes, we'd say, no, we couldn't. No, we couldn't because mean standard deviation would return a list.
Oh, right. Then we need to apply.
Would we want mean variance or mean standard deviation? Which is the right thing? Yeah, it's mu plus minus sigma, right?
Yeah, I think we will.
Not. That's a very long, ponderous thing. I mean, that seems like a somewhat useful function, thing to have, but
in the family of Riem and friends.
Yes, right. Okay, but let's talk about the around case, because I mean, this is clearly a useful thing to have. Take empirical data and figure out what the around approximation is. Around approximation, I hate that. What are analogous functions? So we're taking well, another possible name would be mean around. Which, because it's taking a mean, but it's giving the around version of the mean instead of just the mean itself, instead of just the number. That's absolute silence. I don't think that's crazy, that name.
It doesn't sound right to me.
Okay. Well, what would you, I mean,
what about, I know you probably not like a two around, and then it would eat lists and distributions.
I just think that's really weird.
I do agree. It has a weirdness.
Because, I mean, there's a computation. Usually the two functions are very structural. And no, we cannot have a roundify.
Maybe you can have empirical round.
This is one of these situations in which sometimes we add a second argument to specify the type. So mean, comma, around could return that.
Doesn't mean already have a second argument? No, it does not. I'm not a huge fan of that. Someone on the live stream, B-Champ on the live stream, suggests list around. Yeah, unfortunately, the problem with that is I mean, there's a certain argument that by the time you have list plot, it's making a plot from a list. But I have a feeling most people, if they see that, will think somehow a list is going to come out.
But then we would need also a different one for distributions if we have an explicit list.
Yes. Also suggest on the live stream empirical mean. I think empirical mean, all our means are empirical means in a sense.
Yes, the mean operates on the data. It's empirical.
Well, okay, so the claim here is we want something where around can either be applied to a list or, I mean, but we said previously that around on a distribution.
No.
Well, okay, there's a much more basic question. Around on a distribution can just go ahead and just do its thing. If you just give but now what happens? So right now, if I say around 4, 5, 6, 1, 2, yeah, okay, here's an obvious question. Why don't we just make it be around itself?
Well, the current implementation supports a vector in the first argument with a matrix of correlations in the second one.
Yeah, but what if you don't give a second argument? What if, okay, so what if around, maybe this is a bad idea, but, and it's making me, what if what happens is, in this case, for example, this says, I've got all these things, I'm going to form a single number, but I'm going to assume that all these, that's kind of stupid.
There seems like a rare case that you want this. Normally you want to infer the mu and the sigma from the data.
Yeah, I agree. Right, but that's the case where I've got, is it crazy? I think it's crazy to have this turn into a single around. I don't think it's the right idea.
No, and I think we need something more general, because sometimes you want, for example, the deviation with its error, because there is a notion of the error of the estimated deviation. So we don't only need something returning the mean with a deviation. We need other things of the data.
By the way, while you were away, I kept on saying about.
Yeah, I've noticed that. That's why I said it at the beginning, that you typically go to.
Well, what do other people find they're saying?
I'm used now to around, and I find it a bit more space meaning.
Yeah, no, I know. What about the other functions here, like plot around or something like that? What are we calling what are we calling the plots that have, or we don't need to have those. It's just that they're supported in list plot.
Right. They have options with names like error bars and things like that.
Yeah. Okay, so listen, we've got a function to name here. For taking this list, what is it really doing? It's estimating.
Gotcha. What about the fitting functions?
And we should also think on the case of the multivariate case, where we do have, say, a set of vectors, and we want to infer from this correlations.
Right, exactly.
I see. So you're saying the case where every one of these is a 2 vector, for example.
Right.
And also, how do you represent the vector values? So it's a single round, or do you have to put the vector of the rounds?
No, you can have an around. So I'm completely wrong. This idea of mine here is just wrong. Okay. So this case here, we need to. Yeah, Michael is right. We have to deduce also the correlation matrix.
Right.
We need really something like data to around or something like this.
Yes.
But these are some sort of estimators with uncertainty. So each thing estimated will come with its uncertainty.
See, around estimate. Yeah, I don't like it. Anything with estimate. We've got all kinds of other estimated this, that, and the others. You know, if we weren't saying, if a round value wasn't allocated to something else, which I think it's better allocated to, that would be another possible thing here.
We could feed data in the first argument of a round value, and then depending on what we have in the second argument.
That seems unbelievably hacky. I mean, on the one hand, a round value would take apart an around, and on the other one, it would create an around. That seems very hacky. I mean, it's you know, some conservation, some name conservation thing. Okay. I don't believe in that. Let's see. What's another example? What would be a synonym for? See, I keep on going back to a round estimate.
Or you can say find a round.
Estimated around.
Find around is very weird.
We have find feet and so on.
I know.
Yeah, but there isn't really a find. It's fully deterministic.
But I think we are putting too much emphasis in the around here. So the emphasis should be in the operation performed, and then something inside should say, and I want my results with uncertainty. So how would we compute all these numbers without the around right now?
Well, you know, that's why I like mean around.
But mean is only for mean. What happens if I want the deviation as an around? So because the deviation also has an error. And what about the covariances with an error?
Well, okay, so that's you're making an argument for your thing about the second argument of mean being around.
But I'm worried that we might need it also in standard deviation and other things that may be too problematic. So perhaps we need a function that says, I want to estimate things about this data, and I have to specify what I want to estimate.
Well, so that would be, you might be proposing there something about estimate around f comma data, where by default f is mean or something.
Yeah, perhaps. But it could be also standard deviation or covariance or something.
Does that make sense? I mean, okay, so yeah, right. So this is the interface between data and, yeah, I mean, it's like apply around or something.
We have all these, we have all these fitting functions. So when we have the correlation factors and things like that, those are things that could be returned with estimated errors.
From the fitting functions.
Right. So we have data and we want to feed a linear function.
Yeah, I mean, there's all kinds of places where we can return this. I mean, a lot of machine learning functions could return these.
Right, exactly. So that's why I think that perhaps we need some way of specifying, give me the results with errors, rather than introducing new functions.
I'm skeptical because I think that if the first argument to estimate around or something is some arbitrary long program, without some sort of automatic differentiation game or something, it's very hard to see how we would possibly do this.
Yes.
Mm-hmm.
Whereas, this case is by far the most common case. That is, I've got a bunch of empirical data and I want to know, I want the
it's really a version of dimension reduce.
Well, that's a very weird way to think about it, but yeah. Okay, so we've got a function we need to name here.
I have to run to external interview.
Okay, and I also need to go. George on the live stream is agreeing with us that it's not going to work to overload mean and things. All right, we've got quite a bit more to go through here. I mean, this is at least another hour. I would think. I don't even know what some of this stuff is.
So these are examples taken from the GAM documentation, just to show that with this functionality, we can solve those examples.
Okay. Let's schedule another hour on this stuff, and and let's invite Gosha to the next iteration of this.
Yep.
Somebody on the live stream actually asked about relative errors, and there they are. But we need to go through these.
Right.
Okay, this is really wonderful functionality. This is very exciting stuff. We've been waiting for this. I've been waiting for this for 30 years. SMP used to have a numbers with errors mechanism, but it's been gone for 30 years. So great stuff. Okay, thank you to everybody on the live stream. Bunch of interesting comments today. Appreciate it, and talk to you all soon.
Bye.
Bye.
See you. Bye.